Hi, I'm Rich with insideHPC. We're here at ISE 2019 in Frankfurt, Germany, and today I'm here with Raj Hazra. Raj, thanks for having me today. I just watched your keynote. I was wondering if you could summarize it for me. There's a lot of intriguing points about what's changing here in the world of HPC.
Hey, Rich, good to see you again. It's an exciting day, and it was a wonderful opportunity to talk to my friends here in the community about a large number of interesting things. But you know, the underpinning of that is this movement towards the convergence of what we have traditionally called high-performance computing, which is modeling and simulation, and this new burgeoning world of artificial intelligence. So what I talked about was, if we see the future as convergence of HPC and AI, what must happen? What must happen through innovations in hardware, in software, and why should systems be constructed differently than we constructed it up until now to accommodate the needs of both HPC and AI?
Okay, does that center around data, or where does it come? Where is the big paradigm? Yeah.
The big paradigm change is how we deal with data, even in memory, all the way out to storage, as well as how we deal with the notion of computing near data, right? So what I talked about, one of the big things I talked about was DAOs. And it's DAOS stands for Distributed Asynchronous Object Store. And literally for decades now, we've always thought of data on our computers as files, right? But when you get to artificial intelligence, it's not just dumb blocks of data. They have meaning to them, they have key value associations, and they can't be stored or retrieved as just blocks of dumb data in a file. DAOS changes that. DAOS changes it by giving it a representation that makes it easier to access both traditional data, file data, but also this new kind of AI data through a new representation. What's most exciting is I talked about Intel Optane Data Center persistent memory, and this new level of storage class memory uniquely enables DAOS's promise by making it really, really performant and efficient. Without Intel Optane Data Center persistent memory, it's impossible to implement these massive, massive convergence innovation like DAOS.
You talked about some of the technologies besides DAOS that are coming together for the Aurora system, the first exascale machine to be delivered in the U.S. And Optane persistent memory as well, right?
That's right.
Yeah.
Yes, I did talk about two other things. I talked about what's in Aurora, and my goal was to point out that these systems don't just become larger by adding more and more cabinets. They become larger, true, but they also get the ability in the infrastructure, such as how you program them, how you manage them, and how you run efficiently on them in order for these large-scale systems to be very useful and deliver to their mission. So I talked specifically about lightweight kernels as a paradigm change in how code runs on a node. I talked about a unified control system that gives us system-level visibility across hundreds and hundreds of racks in order for us to manage and service a system. I talked about PMIX, which is an infrastructure orchestration so that you can improve things like MPI job starts by a factor of 100. And so it's chock full of innovations. I did also talk about our Xeon roadmap. And I don't want to let that go, because for us, Xeon represents the tip of the arrow in this paradigm. Many data center CPUs exist, and several of them have innovated in the traditional vectors around more memory bandwidth, more cores. I mean, Xeon's been leading in that respect for years now. What we've done is added specific capabilities to Xeon called Deep Learning Boost, or DL Boost, for AI specifically. So what you have is the hardware acceleration for AI workloads, but in a Xeon infrastructure, in a programming model that's well understood and supported by the ecosystem. And that's also a very, very important and impressive and exciting for me personally move towards the convergence of HPC and AI.
Well, great. It's great to hear about all these technologies that are going to have to be there to make this dream possible. And thanks for having me. You did a great job.
Thank you. Thank you again.